Hi everyone. In this video, we'll be solving another Leetcode problem called valid palindrome. We has to write a function which returns if the given string is palindrome or not. If the given string is palindrome, we have to return true, otherwise false. And how do we define palindrome? So this is how we define: converting all the uppercase characters into lowercase and removing all non-alphanumeric characters. It reads same if we read from forward or backward. Alphanumeric characters include letters and numbers, so very simple. If we take the first example, we have some uppercase characters and we have some spaces and non-alphanumeric character. So if we remove everything and convert uppercase into lowercase, this is the string we'll get. If we have converted a to lowercase and we have removed comma, space, colon, and whatever is the non-alphanumeric character. Now it becomes palindrome because if we read from the forward or backward, it is same. So that's why for this input our function should return true. For the second example, this is the string. If we remove space, which is the only non-alphanumeric character given, so this part is palindrome, but EA will break the property. That's why we will return false. Last example is with single character and empty string. So this is again non-alphanumeric character. If we remove this, it becomes empty string, and empty string is always palindrome, or string with single character is palindrome. That's why this should return true. So let's see how we can solve this problem. If we forget about the problem and take a simple string S and see how do we check if a given string is palindrome or not. It don't have any special characters or non-alphanumeric characters, just has lowercase characters, so we have to check if a string is palindrome or not. So how do we approach? We take two pointers, left and right. Left is at the beginning and right is at the end, and we compare the characters present at left and right pointers. S of left is equal to S of right. If they are equal, we move towards the center. We move left by 1 and we decrement right pointer by 1, so that left and right moves towards the center. And if they are not equal, we know that the string is not palindrome. We break and return false from the function. So M and M are equal at left and right. Then we move towards center. We'll move left by 1, it points to A, and this also points to A. These are also same. So effectively we are comparing S of 0 with S of 8 initially, because this was my left and this was my right. Then S of 1 by S of 7, then S of 2 with S of 6, and finally S of 3 with S of 5. Now we have only one character left, and single character is always a palindrome, so we don't have to check that. So if all the characters we have to compare are equal while moving towards the center, left and right, which means that the string is palindrome, otherwise we'll break. Now everything remains same, it's just that we have introduced some special characters between the string, or some special characters, and at the same time some characters are in uppercase also, some are in lowercase also. So this is the next example where the string is same, it's just that we have introduced some special character like at the rate, and then it has some spaces and so on. So we'll follow the same approach. We'll take two pointers, left and right, and before comparing these two characters, we see if the current character at left and right are alphanumeric or not. So at left it is alphanumeric, so we are good. At right it is not alphanumeric, so what we'll do, we'll skip all those characters which are not alphanumeric. So we'll keep on moving towards center. We'll skip dollar, we'll skip at the rate, we'll skip percentage, and we eventually land here, which is now alphanumeric. Now both are alphanumeric. We'll compare S of L and S of R. These are same. We move one step towards center for both left and right. Left and right. Now we see at left this is not alphanumeric, so we has to skip this character. We move one step, again this is not alphanumeric, we'll move ahead and we eventually land here. And same goes for the right pointer also. We encounter a space, we have to skip it, we'll land here. And then we'll compare the two characters which are at left and right pointers are same or not. So here we have same. So similarly we'll follow the same approach. We'll keep on skipping the non-alphanumeric character. If we encounter alphanumeric character at left and right, we compare by converting it to lowercase, because string because characters can be uppercase or lowercase. We'll compare. If they are same, we'll move towards the center, skipping alphanumeric characters. And whenever we see alphanumeric character and they are not same, we'll break and we'll say the string is not a palindrome. So this is what we can follow to solve the problem. So let's go back to Leetcode to solve this. As we saw, we has to take two pointers and keep on comparing and move towards the center. So we'll take two pointers, left equal to 0, which is at the beginning, and right at equal to length of string minus 1, which is at the very end. Now we'll run the loop until left is less than right, and if s of left is not equal to right, will return false, and we'll increment left and decrement right, and at the end we'll return true. So this is a very simple program just to check if a string is palindrome or not, irrespective of it has special characters or not, we have to remove or not. This is the very simple program to check if a string is palindrome or not. Now we can accommodate whatever conditions are given to us, and we can update our program accordingly. So first requirement is convert all uppercase to lowercase. Okay, while comparing we'll convert it to lowercase. Very simple. Now we has to skip all the non-alphanumeric characters. Okay, what we'll do, we'll run a loop while left less than equal to len of s and not s of left is alnum. So is alnum in Python is a predefined function using which we can check if a character is alphanumeric or not. And this is the additional check to avoid going out of the bound. So we'll actually move left plus e equal to 1 until we encounter a alphanumeric character. That's why we have to add this condition to avoid out of bound errors. Similarly, we'll do for right pointer also. While right greater than equal to 0, right moves towards the center from the end. That's why the check should be greater than equal to 0 and not s of right is al num. Similarly, right minus equal to 1. So yeah. Another check that we have to add is in this condition. So there can be possible that while moving left and right to check if the current character is alphanumeric or not, we may end up going out of the bound. So here also we'll have to add this check. So we have to check right should be more than equal to 0 and left should be len of s, and then our main condition to check if characters are same or not. So that's it. If they are not same, which means that we have found a character which breaks the property of palindrome. Otherwise we'll continue, we'll keep on moving towards the center, and at the end if we don't find any character which are not same, which means that the whole string was palindrome. That's it. Let's run this. Take all the examples. Yeah, works. So I'll submit this. Great, got submitted. Finally, we can check what is the complexity of this program. There are a couple of loops that we are running. So very outer loop takes order of length of a string, because we have taken two pointers at the corners of the string, and we are moving towards the center. That's why this can take at max order of length of string. In fact, length by 2, half of the length of the string. But let's remove the constants and take order of n. N is the length of the string. This would be the time complexity. And although there are in a string of loops, this does not mean that we are doing n squared, because in the inner loops also we are updating the pointers of the outer loop itself. So we are further moving the pointers towards the center. That's why the overall computation we are doing is bounded by the length of the string, and the space complexity will be order of 1, because we are not taking any additional space in comparison to the length of the string. We are taking couple of variables like left and right, and then in these functions also, these all are order of 1 operations, these functions that we are calling, and then we are comparing just the characters. So we are not taking any additional space. That's why the space complexity will be constant. So the time complexity is order of n, and space complexity is order of 1. So that's it for this video. Thanks for your time. See you in the next one. Bye.